this graph. This is where we left off in our last session. We saw that the sine function is an onto function, as for every y value in the range 1 to -1, there is a corresponding x value. But it is not 1 to 1 as it does not pass the horizontal line test. We see that the horizontal line cuts the graph at more than one point. So we come to a conclusion that the sine function is not naturally invertible. In this session, let's see how we can make this function invertible. Currently, this function is not invertible as it's not 1 to 1. So we can make it invertible by making it 1 to 1. This can be achieved by restricting the domain of this function. Let's understand what we mean by that. The domain of the sine function is all real numbers. But we just saw that for this domain, sine function is not 1 to 1. Now look at the graph and focus only on this span, which is from x equal to -π/2 to x equal to π/2. For any point on the graph within this span, the corresponding value of x will be unique. Or in other words, the horizontal line test is satisfied within the span. Now the sine function becomes 1 to 1, and we had earlier seen that the sine function is always onto. Therefore, the sine function is invertible in this restricted domain. Or in other words, sine inverse exists for this restricted domain. Actually, the sine function restricted to any of these intervals is 1 to 1. And therefore, the inverse of sine function exists in each of these intervals. The inverse of sine function is denoted like this. Or it can also be denoted like this. It is pronounced as arcsine. Suppose we have a function sine y equals to x. This same thing can also be written as sine inverse of x equals to y. Before we move on with this topic, there's one confusion we have to clear. Is sine inverse of x the same as the reciprocal of sine x? Let's say that you have x to the power -1. We know that this equals 1 over x. So this represents the reciprocal function. However, that's not the case here. These two are not the same. Sine x, the whole raised to the power -1, is the reciprocal of sine x. However, if you see the -1 as the superscript next to sine, and it doesn't affect the whole thing, then that's not the reciprocal function, that's the inverse function. And this is the reciprocal here. If we look at this graph, we understand that the range of sine x is from -1 to 1. So sine inverse will be a function whose domain would be -1 to 1, and the range could be any of these intervals. This is because in all these intervals, the sine function is bijective and hence invertible. Corresponding to each interval, we get a branch of the function. Of these, the branch with the range -π/2 to π/2 is called the principal value branch. So the domain of sine inverse function is this, and its range is this. And this is how we write it. The value of an inverse trigonometric function, which lies in the range of the principal branch, is called the principal value of that inverse trigonometric function. So how does the graph of sine inverse function look? Let's continue this in the next lesson.